In mathematics, there is the idea of an arithmetic progression, also called an arithmetic sequence, which means you start at some number, and in mathematics you could call that x sub 0, and then you add some fixed quantity to x sub 0 and get the next number in the sequence, and then add that difference number again and get a new number. So for example, you could start with let's say -5, and then add 3, and you get -2, and add 3, and you get +1, and add 3, you get +4, and so forth. In Excel, this process of adding the same fixed quantity can be implemented in more than one way. For example, I could start with -5, that's my x sub 0, and then I could say, in this cell, I'll put a formula that says equal the preceding cell plus 3, and now I have a -2 just as above. But the thing is I can repeat this formula by selecting to the right and going Control R, and now I get an arithmetic progression automatically. And that's done with formulas. So let's see the formulas that I did there. There are the formulas, and that's one way to do it. Well, actually, now you're looking at two ways to do it. One, you could do it in your head, or you could do it with a repeating formula. Or, here's another thing you can do in Excel. It has the idea of an arithmetic progression built in. So again, if I start with -5, and I just tell it what the next number is going to be, okay, and select those two cells, and then go to the lower right-hand corner, and you see the cursor change like that, and drag to the right, then it automatically fills in the arithmetic progression. Here's another way to do this, same sort of thing, except now I'll define a new Excel variable, let's call it DLTX. That stands for delta x, and my value for delta x is going to be +3. And to define a variable named delta x with value the cell to its right, I go to the Formulas tab, and I say I want to define a formula. So create from selection, and just click on that. And now I like to take a defined variable and put it in a box and highlight it in yellow, let's say. And also, let's not forget to check that it really is defined. So I go to the Formulas tab and select the Defined Names thing, and just click on the Name Manager, and there's delta x in the Name Manager. Now I can use delta x for my progression. Again, I'll start at -5, and I'll use the formula method. I'll go equal the preceding number plus delta x. And now I get that -2, and that formula I can repeat to the right as usual by selecting to the right and going Control R. No problem there, but now the fun thing is when I have a variable named delta x, if I change the variable value to, let's say, 4, then all of my numbers in the sequence change automatically because they're defined by formulas using delta x. And I can even make a negative value for delta x and say -1, and now it goes from -5 downward. Or I can use a decimal number. I can say 1.52, and now it's doing very much more decimal arithmetic, and that is yet another way to deal with arithmetic sequences in Excel. Not only can I go to the right, I can go downward. So I can take this formula, put it in here, equal the thing that I started with, and add delta x to that, and go downward and copy that formula down. And now I get the progression going downward. And I can change this back to 2, let's say, and get that sequence. One of the standard things to do in our work with histograms is we had to create bins. Remember bins? Well, you might want to have 20 bins from 0 to 100 with width 5. So what we could do is we'll make our delta x into 5, and we'll start at 0, and now we have bins from 0 to 75, and of course I could drag that down and go to 100 if I wanted to. So this mechanism built into Excel is very flexible for creating arithmetic progressions. In our statistics course, we know that from -3 to +3 is a very important range for values of the standard normal distribution. We want to make graphs of functions in that range, so we'll need some values of -3 to +3 separated, let's say, by, I don't know, 0.1. So I'll make my delta x equal to 0.1, and I'll start at -3. And since I want to go to +3 by 0.1, well, from -3 to -2 is going to be 10 of those. And so I need 60 altogether, because I'm going from -3 to 0 and then from 0 to +3. But the screen only shows up to like 48 rows here, so I'll tell you what I'm going to do. I'm going to split the screen by going to the View tab, and there's a screen splitter here. I don't need a vertical split, but I like this horizontal split. I'll put it down to about here. And what I'll do is I'll go to like about row 60, but since I started away from the top, I may go to maybe 76. Let's see how far I get. So if I go from -1.5 to 77 and fill down, I get to +3. That was an accident. I just lucked into that. Okay. But I do like to see it as decimal numbers, not mixed whole and decimal numbers. So I'll tell you what, I'm going to select this column and go to Home and give myself numbers rather than general. And now they're all 2-digit decimal numbers. Fine. So this range from -3 to +3 is where I'm going to define various functions and graph them. And I want to just demonstrate some of the possibilities for making graphs. But let's start very simply. Suppose our function is just to take that input value. Let's call the input value, I'll call it z. That's reminiscent of what we do in the standard normal probability distribution. We call it the z-score. And let's just put that in the middle, make it bold, and that's my input, z. And I'm going to have various functions that depend on z. For now, I'm going to be very general, so I'll just say that my function value is going to be called y. Okay, but I'll make that bold, and I'm also going to center it. And let's say y is just equal to z. Okay, so I say equal, and then click on the corresponding value that it's the input. So of course, now to fill in that formula all the way down, I select the top value, hold down the Shift key, click on the bottom one, and use Control D to fill it all in. Very easy to graph this. I'll just select everything, including the names, down to the bottom here, and go to Insert. And what kind of chart will we insert? I don't know. Let's a bar chart. Well, a bar chart is always fun. So there's a bar chart of the simplest possible thing I can imagine. It goes from 1 to 61, but we want it to go from -3 to +3. So it's not really showing what we would like. And so let's redo that. I'll do a Control Z to get rid of that. But what I'll do is I'll put in the right end label for my input column. I'll just call it end. Okay, and now when I select all of this, well, I definitely want to just select it from here, hold down the Shift key and get the cell to the right of end, and now insert a chart, let's say a bar chart. Okay, so now it goes from -3 to +3 on the horizontal axis, and from -3 to +3 on the vertical axis. And there are all kinds of things one can do to customize this chart. I'm not going to go into that. those are toys that anybody can play with, but one of the basic ways to deal with that is to right-click on this and, right-click on one of the values here, and you get all kinds of things to play with. And we're not going to do any of that. What I do wish to show you is that you can graph more than one function at the same time. So let's take this chart away. I'll select it and delete it. And let's suppose I have another function, I don't know, I'll call it U, capital U, just to be different. Okay, so I put a U there. Again, I like to center that and make it bold. And instead of just the simple linear function y equals z, how about we use y squared? Okay, so this is going to be equal to, take this y value and square it. Okay, so negative 3 squared is plus 9, that makes sense. And so I'll select the top cell, hold down the shift key, click the bottom cell, control D, and get all of that. Now, here's what I'm going to do. I'm going to select all of the columns, but now I have two functions defined on the same z-score, and I will insert a chart now. I can even see what it's going to look like when I click on the Insert Chart button there. That's fun. We can even say OK on that, and there it is. But I would like to click in this thing to call it Y and U. Actually, that's a lowercase y. Call it lowercase y, and capital U. Okay, so, and they're in different colors. Isn't that nice? And you can see down here that we're given that automatically. Very nice. Let's do a third function. Now, I cheated a little bit here because I made U depend on Y, which depends on Z. And that's okay because Y was equal to Z. But I really want to make everything from now on depend on Z directly. So let's make another function called a capital V. And again, I'm going to center that and make it bold. And V is going to depend on Z, but I'm going to cube it. So now I'll go Shift 6 to get the caret for powers, and I'll make a cube out of it. And I select, and yes, negative 3 cubed is negative 27, right? Because negative 3 times negative 3 is plus 9, and then multiplied by negative 3 is negative 27. Okay, select that, hold down the Shift key, click on the bottom one, do Control D. Now we get all of that. Go to Insert. Well, okay, I got to select the things I'm going to graph, so let's be careful here. Select that, go all the way down to the full end, and Insert, and we're going to have a recommended chart, and I'm going to do all three of them. So I'll click on this thing and say OK. And look at that. You see, now you have a linear, a quadratic, and a cubic function in 3 different colors, nicely labeled. I could change the chart title, but never mind that. I just wanted to show that with a single z-score from negative 3 to plus 3, I can graph on the same chart more than one function, in this case 3 different functions. And that's going to come in very useful for the more advanced work that I would like to show you now, to do with comparing the normal distribution to the t-distribution. Using this same setup from negative 3 to plus 3, let's make a graph of the standard normal probability distribution. So we know what the formula for that is. Equal norm dot dist, open paren, and for our z-score we just click on the z value over there, and we're using a mean of 0 and a standard deviation of 1, and we're not doing cumulative, so we just have 0 over there, or so it would seem. If I expand the number of decimal places on that, you can see that it's not quite 0. Let's do it to 5 places and Shift and click to fill down to the bottom. Control D. And now we have a nice set of numbers. Let's graph this as usual. We'll use again the recommended charts, and we see, let me bring this over so you see what I was using last time and you didn't quite see it. We can actually leave off the dots and just make a very nice bell curve. Let's put that over here. Okay, very good. And it goes from -3 to +3. You know what we can do though? We can define Excel variables to stand for the mean and the standard deviation and use those values in this function. So let's take this away. I'll select it down to there, delete it out, and create, let's say, a variable called MEAN, and start it at 0. Create another variable called standard deviation, STDV. You know that I like to use 4 letters to name things, and that'll start out at 1. Let's make these into decimal numbers using number rather than general. And I'm going to define these at the same time using formulas. Define names, create from selection, yes from the left. Let's organize these a little more nicely. We'll get, I like to put them to the right, let's say. And put them in a box. Get them highlighted. And also remove the bolding from both of them. So now we have a bunch of variables. Let's just check using the name manager to see that they're there. Yep, there they are. Fine. And now you see I can use the names of these variables in my formula for the normal distribution. So norm.dist, get my z-score as the input. It's really more general than a z-score now. Usually we reserve the z in z-score for the standard normal distribution, but nobody's paying any attention, so we'll just use that, STDV, and still we're not going to accumulate it. We get a number, and run that down, Control D, and let's graph that again, and insert a chart, and it looks exactly the same as before, except now you see we can go play. Let's suppose we move the mean to -1, then the graph moves over. See, the vertical is at -1 now. Or I could move it to +0.5, and it moves it over to there. Or I could change the standard deviation. I could reduce it to, let's say, 0.4. And you see now the graph is higher and narrower, so that the total area, or the total probability underneath it, is still 1. Make it even smaller. That would be interesting. 0.04. And it's a real, almost a spike. Notice that it's going up to 10 now. That's very high. There's a reason for that, because 10 times delta x is 1. Let's not go there right now, but that's something to explore and think about. But let's put it back to the usual of 0 and 1 for the standard normal distribution. And what I want to do now is to compare that graph. Let me take it away so we can make a double graph. Compare that to the t-distribution. Now, you know that the t-distribution depends on the number of degrees of freedom. So I need another variable. And I'll put it over here. I'll call it DEGF. And we'll start it off at, let's say, 4. course, that means that the number of samples is 6, because remember, at least in the situation we are dealing with regard to correlation and regression, the number of random variables is 2. So we subtract 2 from the number of samples to get the degrees of freedom. I have to define this variable. We'll go to formulas, define names, create from selection, and as usual, put it in a box, highlight it, and now we go and double check that we have the names. Yep, there's degrees of freedom, no problem. And so we can use that in our definition of equal t.dist. Again, use the z-score. I would really call it something else if I'm dealing with a different probability distribution, but z is z. And we want to put in the degrees of freedom, so we go DEGF. And we're not going to accumulate it, but we do want to evaluate it. Notice right away, even just at -3, that the t-distribution has a fatter tail, whereas the normal distribution was 0.00443. Over here it's 0.02. Let's give it some more decimal places just to make it officially similar to what we were doing before. It has to be a number. And now give it more places, give it 5 places. So we can compare that clearly the tail is fatter. Well, we'll see that in the graph. So anyhow, select that, shift, go down there, fill it in, and now we can do a graph of the normal distribution and the t-distribution together by inserting a recommended chart. And we want both of them. That's this one here. It doesn't look like we're going to get a smooth curve. Well, we'll use the dots. And we'll say OK. And there is a very interesting comparison, you see. And look, first of all, as I said in class, the t-distribution is just as symmetrical as the normal distribution. It has this same center. For the moment, never mind the fact that I'm not going from -3 to +3. But let's just look at the shapes of the graphs. The orange graph is the t-distribution. It has fatter tails. You can see that very clearly here and over here. But let's change the number of degrees of freedom. First of all, let's make it 1. And the tails are even fatter. You'll notice that the peak decreased because the area under the t-distribution, as for any probability distribution, must equal 1. So if you're going to raise the tails, you have to lower the peak. On the other hand, let's go to a degrees of freedom, let's say, of 100. And now, you see, my whole point is that when you increase the number of degrees of freedom, the t-distribution pretty much goes in the limit towards the normal distribution.